Hello, so this is a video for year 10 and this is sample space diagrams. So this lesson we're going to learn how to use a sample space, what they are and how to use them. So to start off with, I want you to answer this question here. Now this was in the November GCSE paper, the one that my year 11s just took for their mocks, and lots of people didn't do this question very well. So although hopefully you'll find it fairly straightforward, it is something that goes wrong, so it's something worth spending time on. So the question says, a fair coin has heads on one side and tails on the other. The coin is then tossed 3 times. Write down the possible outcomes, e.g. or i.e. what could happen. Try to be logical. So you just need to write down what are all the options that it could be. I want you to pause the video now and try it. What are the options? Okay, so hopefully you've paused and you've had a go yourself. And let's see if you got the options that I got. So I got first 3 heads. Heads, heads, heads. Then I got heads, heads, tails. Then I got tails, heads, tails, heads. Then I got heads, tails, tails. Then I got tails, tails, tails. Tails, tails, heads. Tails, heads, tails. And finally, tails, heads, heads. So there should be 8 options altogether. When a coin is tossed 3 times in a row, what is the probability of getting exactly 2 heads? So exactly 2 heads is here. Oh, it didn't let me draw. Let me draw last time. Is this one? It's not going to let me draw on it. This one here. This one here. And this one here. So that's 3 options that you get exactly 2 heads. So that's 3 out of the 8 options. So the probability is 3 out of 8. So, sample spaces. Sample space can be used in probability to help you be logical. Okay? It usually is drawn as a table to show the possibilities when 2 events are being considered together. Once the sample space is drawn up, you can more easily answer questions like in the starter. So, first question, sample space to show the possibilities when a coin is tossed and a normal 6-sided dice is thrown. So, the dice could give us any number between 1 and 6, and the coin could be heads or tails. So if we draw a grid like this, we can have dice along the top and coins down the side. So the dice is 1, 2, 3, 4, 5 and 6, and the coin is head or tails. So our options, so to go in this box here, you've got a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6. You've got a tail and a 1, a tail and a 2, tail and a 3, tail and a 4, tail and a 5, tail and a 6. So what is the probability of getting a 3 on the dice and a tail on the coin? So we're looking for a T3, so there's only one of those options out of 2, 4, 6, 8, 10, 12 options. So that is 1 out of 12. Okay, so reasonably straightforward, hopefully. Right, sample spaces. 2 tetrahedral, that's 4-sided, dice are rolled and their scores are added together. Draw a sample space to show all the possible outcomes. So, dice 1, we've got 1, 2, 3 and 4. Dice 2, we've got 1, 2, 3 or 4. This time to fill in these, it's not 1 and 1, it's 1 add 1. So 1 add 1, 2. The next one, 1 add 2, 3. 3 add 1, 4. 1 add 4, 5. 1 add 2, 3. 2 add 2, 4. 2 add 3, 5, etc., etc. You can see how they're filling in. Then you'll get a question like this. So that would be part A for a question. Then it says, what's the probability of getting a 6 or above? So we're looking at all the ones that are 6s or above. So we've got those, those and those. So in total I've got 1, 2, 3, 4, 5, 6 out of 2, 4, 6, 8, 10, 12, 14, 16. So I've got 6 out of 16. Now it's a probability, so I don't have to simplify, but you can simplify to 3/8. So it depends on the question with probability whether you want to simplify. You'll never be marked down for not simplifying with probability. Other things, yes, you'll get marked off. But for this, you'll be fine if you don't simplify. Right, some more questions. So I spin 2 spinners, then add the numbers together to get a score, work out the probability. So I've got a thing. I was hoping I could write on this. All right, well, let me write now. So the first spinner, I've got options of 1, 3 and 5. The second spinner, 1, 3 and 4. Now, it doesn't say it in the question, but I'm going to presume that these are fair spinners. They look like they're thirds. It looks like there shouldn't be an issue. So I am adding them together. I want to draw. Let me draw. I want to add them to draw. Pen. Oh, it's not letting me draw. So in here, it's not letting me draw. 1 add 1 would be 2. 1 add 3 would be 4. 1 add 5 would be 6. 1 add 3 would be 4. 3 add 3 would be 6. 3 add 5 would be 8. 1 add 4 would be 5. 4 add 3 would be 7, and 4 add 5 would be 9. How many of those then got the answer of 4? Well, that was the 3 and the 1, which made a 4. The 3 and the 1 made a 4, so that was 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting 4 is 2 out of 9. So I want you to pause, and I want you to try this next question here. You can see it's very similar to this one. It's just one number is different. Okay, so it should look very similar to this question, but one number is different. Pause the video, have a go for me. Okay, so your first spinner should be 1, 3 and 5. Second spinner, 2, 3 and 4. Again, you're adding them up. So 1 and 2 is 3, 5, 7, 4, 6, 8, 5, 7, 9 should be your values in there. Probability of getting a 4, you can only get a 4 here, so it's 1 out of 9. Okay, so hopefully you've got the idea of how to fill out the space diagrams and how to find a probability from it. So there's going to be some questions up on your screen now. Here we go. So there's 6 questions on the screen now. Again, assuming they're all fair spinners. I want you to have a go at these questions. So pause the video, have a go. And then once you're done, unpause and I will go through these questions with you. Okay, so to go through these questions, I've got to just do this because it's not letting me write. So I spin these 2 spinners and then add up the numbers, work out the probability, I get a score of 4. Okay, so spinner 1, I've got the option of 1, 3 and 5. Spinner 2, I have the options of 2, 4 and 6. So I draw my grid out. In an exam, yeah, it would be beautiful if I could use a ruler, but I'm not going to. I'm adding them together. So that's 3, 5, 7, 5, 7, 9, 7, 9, 11. Work out the probability I get a score of 4. Oh, look here. There's no 4s. So the answer for that one is just 0. Okay, the probability is 0. There are no 4s if I add them up. Okay, so question 2. Have a look. What's different between these 2 questions? Actually, the spinners are exactly the same, so I can look back at this one. The question is different. Work out the probability I get a score of 7. I've got 1, 2, 3 7s out of 3, 6, 9. Again, I can leave it like that if I want to, or I can simplify it down to a third. Okay, right. Question 3. Now, question 3 is different. So I am going to use a different colour and I'm going to go here. So spinner 1, I've got the option of 1, 3, 5 and 6. And spinner 2, I've got the options of 2, 4 and 6. Okay, again, I'm adding them. So 3, 5, 7, 8, 5, 7, 9, 10, 7, 9, 11 and 12. What's the probability I get a 7? So how many of these are 7? 1, 2, 3 are 7. This time it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 3 out of 12. Again, I can simplify that if I want to a quarter. Right, question 4. I spin the 2 spinners. I've got spinner 1 has got 1. It's got 1 again. So I am going to put it twice. Just because it's repeated doesn't mean I only put it once. It occurs twice on my spinner, so I need to put it twice. Because it's twice as likely to happen than any of the other numbers, assuming that all the sizes are equal. And then down the side 2, 4 and 6. So again, drawing it like that. It is another add question. 3, 5, 7, 3, 5, 7, 5, 7, 9, 7, 9, 11, 8, 10, 12. Okay, probability of 7, 1, 2, 3, 4 7s this time. Out of a total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that won't cancel down. Okay, let's keep going. Oh, look! Oh no, they are different. I have to keep going. So I need to draw a new one. Spinner 1 has got 1, 1, 2, 3 and 5. Spinner 2 has got 2, 4 and 6. It is another, I spin it and find the difference. So this time, again, I'm glad I read, it's a subtraction. So I'm finding the difference between them. So the difference between 2 and 1 is 1. The difference between 2 and 1 is 1. Difference between 2 and 2 is 0. 2 and 3 is 1. 2 and 5 is 3. 1 and 4 is 3. 1 and 4 is 3. 2 and 4 is 2. 2 and 3 is 1. 4 and 5 is 1. 1 and 6 is 5. 5, 4, 3, 1. So again, make sure you read the question. Probability I get a 7. There's no 7, so the probability is just 0. Okay. Oh, look. Lovely. These ones, you can see the spinners are exactly the same. The question is still a difference question, so I can still use my table from here. Work out the probability to get a score of 4. There's 1. So it's 1 out of how many options? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so those were the answers to that one. I've got more questions again. Surprise, surprise. Oh, no. That's not what I want. So, more questions. Oh, it's come out annoying again. I thought I'd fix that. Sorry. Okay, so this bit's meant to be grey, that bit's meant to be blue, that bit's meant to be orange, that bit's meant to be yellow, blue, orange, grey, grey, blue, orange, yellow, grey, blue, orange. When I change the format from, it's just not saved for some reason, but I'm going to keep going. So try those questions for me, pause the video, have a go. Okay, so hopefully you've tried those. Let's see what we get. So, come on. I find these spinners product. Right, product means multiply. So now I've got 1, 1, 2, 3, 5, 2, 4, 6. This time, I'm not adding, I'm not subtracting, I am multiplying them together. So 2, 2, 4, 6, 10. 4, 4, 8, 12, 20, 6, 6, 12, 18, 30. Work out the probability I get a score of a 4. Well, that's 1, 2, 3 4s out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I want to, I can cancel that down to a 5th, but I don't need to. Okay, next one. This time it's just talking about what numbers come up. So I am going to have to redo my thing. 1, 1, 2, 3, 5, 2, 4, 6. I do tend to write these in number order. I don't need to. I think the reason I do it is because then when I'm doing any calculations, it just helps me spot patterns. Right, so for this one, I'd get a 1 and a 2. I'd get a 1 and a 2. I'd get a 2 and a 2. I'd get a 3 and a 2. I'd get a 5 and a 2. A 1 and a 4. A 1 and a 4. A 2 and a 4. A 3 and a 4. A 5 and a 4. A 1 and a 6. A 1 and a 6. A 2 and a 6. A 3 and a 6. And a 5 and a 6. What's probably going to get the same number? So the same number happens here, a 2 and a 2, and nowhere else. So it happens once out of how many times? 3, 6, 9, 12, 15. Okay. Next one, I spin the same spinner twice. What's the probability I get the same number on both spins? So we've got a 2, a 4, a 6 for this first spinner, and then the second one is still a 2, a 4, a 6 because it's still the same spinner. So we draw our space diagram. So that's a 2 and a 2, a 2 and a 4, a 2 and a 6, a 4 and a 2, a 4 and a 4, a 4 and a 6, a 6 and a 2, a 6 and a 4, a 6 and a 6. I want the same number on both, so that's 1, 2, 3. So that's 3 out of 3, 6, 9 options. Again, you can cancel that if you want to a third. Okay. Right, let's keep going. So, I spin the same spinner twice. What's the probability I get the same colour on both spins? Okay. So we've got a grey, a blue, an orange, a grey, a blue, an orange. Oh. If I'm going too fast at any point, great thing about videos, you can just pause me. Green, 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 blue, green, orange, blue, green, blue, 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 orange. Orange, green, orange, blue, orange, orange. What's the probability? What's the probability the colours are not the same? So I want not the same. So that's they're not the same. 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 So that's 2, 4, 6 out of 9. Again, I can cancel it if I want to 2/3. Okay. I spin the same spinner twice. What's the probability that I get the same colour on both spins? Oh, I didn't answer didn't spot that. I was going too fast. For this one, what is the probability I get the same colour? So the same colour is green, 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 blue, blue, orange, orange, which was 3 out of 9, which was a third. And then the rest was not the same. Didn't spot there were 2 questions there. I was going too fast. Right. Spin the same, so we've got yellow, grey, blue, orange. So yellow, grey, blue, orange, yellow, grey, blue, orange. Okay, so we got yellow, 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 green, yellow, blue, yellow, orange, green, yellow, green, 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 blue, green, orange. Blue, yellow, blue, green, blue, 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 orange. Orange, yellow, orange, green, orange, blue, orange, orange. So I want the probability that they get the same colour. So that's 1, 2, 3, 4. So that's 4 out of, that's 4, 8, 12, 16. which is the same as a quarter. And sorry for the noise in the background. And then what's the probability that they're not the same? But not the same is everything else. So it's that one, 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 which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 12 out of 16, which is the same as 3/4. We should notice that these two should add up to 1. Okay. Then the last question on this section. I spin these two spinners. What's the probability I get the same colour on both spinners? What's the probability they're not the same? So the first one, I've got grey, blue and orange. The second one, I've got yellow, grey, blue and orange. So draw my table. So that's yellow, green, yellow, blue, yellow, orange, green, 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 blue, green, orange, blue, green, blue, 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 orange, green, orange, green, orange, blue, orange, orange. So what's the probability I get the same colour? So same colour, nothing's the same there. 1, 2, 3. So it's 3 out of 4, 8, 12. So it's 3 out of 12, which is the same as a quarter. And then the colours are not the same. Well, that's everything else. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 out of 12, which is equal to 3/4. And again, you'll notice they add up to 1. So those are very basic questions. You are more likely, however, to get questions a bit more like these ones. So these ones are GCSE questions. Again, I'm going to do it one at a time. I'm going to ask you to try it. So pause, you try it. Okay, so let's see how that looks. So, two normal unbiased coins are tossed. Draw a sample space to show the possible outcomes. So unbiased coins, so I could get a head and a tail, or I could get a head and a tail. So these all have to be unbiased, otherwise the chances of them happening is unequal and then we can't do anything about it. So I can get a head, a head, a head, a tail, a tail, a head, a tail, a tail. What's the probability of getting 2 heads? Well, that's that one there, which is 1 out of 4. So that was part B, that's part A. What's the probability of getting 1 head and 1 tail in any order? So it could be that one, it could be that one. So for part C, it's 2/4, or again, you can simplify it down to a half. So hopefully you got that one right. So next question. Question 2. Pause it, have a go. Okay, so hopefully you've had a go now. So I'm going to have a go now. Oops, there we go. 2 unbiased 6-sided dice are rolled and the scores are added together. So I've got options 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This will take me a minute to do. So they are added together. So 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Can you spot the pattern? This is why I would do it. Thinking and talking is difficult. This is why I would do it in numerical order, because then you can spot patterns of how to just add them up quickly. 7, 8, 9, 10, 11, 12. Okay, so that's my space diagram, part A, I. So we've got some introducing, you should have seen this last year. The P and then the brackets means the probability that it is whatever is in the brackets. So the probability that it's even. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 of my options are even. Out of how many options? Well, it's 6 lots of 6, which is 36. Okay. Any of you that are quick, you'll notice that's equal to a half. Okay. Right, part 2. The probability is greater than 8. So that's not equal to 8, it's greater than 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 out of 36. Again, you can cancel them down if you want. That'll be 5 over 18. You do not need to cancel things down if you don't want to. I'm just going to zoom out a bit, otherwise I'm not going to be able to see. Right, question 3. The probability is 2. Well, there's only 1, 2, so 1 out of 36. Just going to, and then IV. The probability is a square number. So we've got to think about our square numbers. So the square numbers, you've got 1 times 1 is 1, so 1 square. 2 times 2 is 4, so 4 squared. 3 times 3 is 9, so a 9 is a square. And then 4 times 4 is 16. 16 squared, but it's not big enough. So I'm only looking for 1, 4 and 9. So there's no 1s in here. So 4, 1, 2, 3, and then 9s, 4, 5, 6, 7. So it's 7 out of the 36. Right, 5, it's a prime number. So primes are only divisible by 1 in themselves. They've only got the 2 factors. So 2 is a prime number because it's only divisible by 1 and 2. Lots of people forget that. It is the only even prime number. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You'll notice I skipped 9. 9 is not a prime number because it's 3 times 3. That's another mistake people often make. Question 6, a negative number. No negative numbers in here. Probability is 0. I'm going to just go up here because I'm running out of space. A factor of 12. So factors of 12 are a number that's divided into 12 exactly. So that's going to be 1 and 12, 2 and 6, 3 and 4. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 out of 36. I can cancel that down to a third. And then finally for this question, it's a long question, a multiple of 12. So that's any number in the 12 times table. So 12, 24, 36, 48, etc. There's only 1. 1 out of 36. So hopefully you got all of those ones right. Let's see if there are any more GCSE questions. I think there's one more GCSE question coming. Here we go. Right. Pause the video. Have a go. Okay, so hopefully you've had time to pause the video. And if not, pause now. And I'm going to try this one. So, 2 6-sided dice are numbered -2, -1, 0, 1, 2, 3. Draw up a sample space outcome to show the outcomes when they're multiplied together. Ah, lovely. Negative numbers. You guys, something we all need to work on. So -2, -1, 0, 1, 2, and 3. And then it's -2, -1, 0, 1, 2, and 3. I'm going to change colour for this because I'm starting to see that I might start counting. Oops. My outside numbers in. Now you won't necessarily have that option in a GCSE because you should only be using one colour pen, but I can use it now. Oh, come on, next slide. There we go. So I'm multiplying these guys together. So -2 times -2 is 4. -2 times -1 is 2. -2 times 0 is 0. -2 times 1 is -2. Spot the pattern. -4, -6. -2 times -1, we've already done that before, is just 2. -1 times -1 is 1. 0 times -1 is 0. Spot the pattern. -1, -2, -3. 0 times anything is just 0. 1 times -2, I've got 1 -2, so I've got -2. I've got 1 -1, so I've got -1. Spot the pattern. Okay. -2 times 2, so I've got 2 lots of -2, so I've got -4. -2, 0, spot the pattern. 2, 4, 6. I've got 3 lots of the -2 now, so I owe 3 people £2, so I owe £6 altogether. I've got 3 people that I owe £1 to, so that's I owe £3 in total. I've got no people. And then spot the pattern, 3, 6, 9. Okay, right, then work out the probabilities as fractions and percentages. Ooh, funky. Yeah, that's fine. P is positive. Okay, so positive, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 13 out of 5 by 5. So that's 25. Can't be cancelled. Oh, and we want to turn that then into a percentage. So to turn it into a percentage, it has to be over 100. So that means I've got to times by 4, because 25 goes into 100 4 times. So 3 times 4 is 12, so 2, carry the 1 in my head. 1 times 4 is 4, plus the 1 is 5, so that's 52 over 100, which is 52%. Right. Part 2, negative. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of the 25 are negative. Again, turning it, so times by 4, 12 4's 48. Okay. Oh! I've been silly. Been very, very silly. Ignore me. What have I done? You can spot what mistake I've made. I can't count. 1, 2, 3, 4, 5, 6 numbers. So it's over 36. Oh, 36 does not go nicely as a percentage. I'd have to do that on my calculator. Don't really want to, but I'll see if I can find my calculator around somewhere. So it's 13 over 36. Thought my numbers didn't work properly. And then what did I say the other one was? 12. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12 out of 36. I'll turn them into percentages in a minute for you. 1, 2, 3. Not positive or negative. So the not positive or negative are all these zeros that I didn't count before. 0 is a nothing number. It's neither positive or negative. Okay, so that's why I didn't count them in any of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 out of 36. And then a square number. So square numbers, remember, 1 times 1 is 1. 2 times 2 is 4. So 1, 4, 3 times 3 is 9. So 9. So we've got 1, 2, 3, 4, 5. So we've got 5 over 36. Again, you could try and argue that 0 times 0 is 0, so 0 is a square number, but it's not, it's nothing, it's not a number, so it doesn't count. Right, let's turn these then into, I've got to find my calculator on here now. Oh, I've just gone past it, calculator. So let's turn these into percentages then, as it's asked us to. So to turn it into percentages, I do the numerator divided by the denominator, and then I times it by 100. And then it wants it to 1 decimal place. So that is 36.1%. The next one was 12 divided by 36 equals, times by 100, 33.3%. 11 over 36 times by 100, 30.6%. Don't forget about your rounding. And then 5 divided by 36 equals, times by 100, 13.9%. Okay, so those are the answers that you should have gotten. Right, so in summary, we have learned about sample spaces. We've seen how they can be used to show all combinations of 2 events happening. We've also seen how they allow us to accurately calculate probabilities. Okay, so that's all there is to sample space diagrams. To prove to me that you've watched this video all the way through, I want you to, on Show My Homework, send me a comment, and I want the comment to say just a single word, star. That way, I know that you've watched this video. Okay, so that's all you need to do. You don't need to show me any of the work you've done. Just send me the word in the comment, star. Okay, if it doesn't work, email me just a single word. It can be the subject, star. Then I know that you've watched it and you've tried it and you've learned something new. Okay, hope you're well, and I'll see you in the next video.